Objective: study the experiment to find out the charge-to-mass ratio of an electron. Atom is the tiniest microscopic particle. Electrons are present inside this tiny atom. Do you know the mass of an electron that is tinier than an atom? Or is there an instrument used to weigh the mass of an electron? Surprisingly, no. How could scientists measure the mass of an electron? The topics ahead will unveil the mystery of magic of measuring the mass of an electron. Let's start our journey. Charge-to-mass ratio of an electron. Once the electron was discovered, J.J. Thomson continued his experiments to calculate the charge-to-mass ratio of an electron. The experimental setup includes a cathode ray tube, it has a cathode, an anode, and a metal plate. A slit is present on anode and metal plate. There is a large sphere at the end of the tube. This is coated with a phosphorescent material, so that the beam, after striking here, creates a spot on it. A scale is provided to measure the deflection. At high voltage and low pressure, cathode rays are produced. In the absence of electric and magnetic fields, cathode rays travel in a straight line without any deflection and strike the tube at point A. When only electric field is applied, the cathode rays deviate from their path and hit the tube at point B. Similarly, only when magnetic field is applied, cathode rays strike the tube at point C. When both the electric and magnetic fields are applied perpendicular to each other and to the path of the cathode rays, the rays shows the deviation. Thomson observed that the amount of deviation of cathode rays depends on three main factors. 1. The magnitude of negative charge on the particle. The more the negative charge, the greater is the deflection. 2. The mass of the particle. The lighter the particle, the greater is the deflection. 3. The strength of the electrical and magnetic field. The stronger the field, the higher is the deflection. By controlling the deviation of the electrons, by varying the strengths of electric and magnetic fields, and accurately measuring the amount of deflection, Thomson calculated the charge-to-mass ratio of an electron. It was found to be 1.758820 into 10 to the power minus 11 coulomb per kg.